answers are online, so you can, after class, you can see. Let's recall some facts, some important things from. All right, quiet down. Find your. How do we do it? Okay. Tell me what the power rule is. How do I differentiate e to the x?
It's e to the x.
How do I differentiate ln x? How do I differentiate? Did I ask you guys this?
It's natural law. Okay, oh my god.
Did I ask you guys? I don't think so. Oh, I got it, yeah. So if you have the derivative of a constant times a function. A constant times the derivative of a function. Or you can write c as same thing.
This is all I have in the test.
What about the derivative of a sum of functions?
Derivative of f. Yeah, over 2.
Yeah, you can just differentiate each part. Yes.
Yeah, so I put n times d over dx and parentheses of x. I put the same thing except I left that is that possible? I left d over dx.
As in, you wrote this here?
Yeah.
That's wrong. Yeah.
Do you get partial credit?
No.
This is pretty good at it.
It's not the same thing. What this means is take the derivative. So if you write n times this of that, you want to take a derivative again. This says take the derivative of that. It's actually an instruction to do something. So you can't, once you've done it, you don't say to do it again. Unless you want to take a second derivative. But that wasn't the question. Yeah, so we had those rules last time. Now we're going to develop some other rules, but first I want to finish with a word problem here. Applying derivatives. And we're going to want to examine things like this further, right? So I know here, if I have a sum or a difference, then the derivative of the sum or the difference is just the sum or the difference of the derivatives. We're going to want to know if that works with all the other operations. Like, does it work with multiplication or division? We're going to figure that out today. But before that, let's actually do some applications. Because we haven't done word problems in a while, and I know you all love word problems. So one example. And there will be a problem like this on the test, so pay attention. And more than likely, there will be a problem like this on the final as well. Yes, we know he had his whole life ahead of him, but he decided to jump anyway. 32 feet above. His height above the water is given by. So I'm going to give you a function that describes his height above the water. I said t equals 16 t squared plus 16 t plus 32. when you guys take physics 203, they're pretty much going to give you a formula that describes this thing, and they're going to tell you just memorize it. We're actually going to derive it in this class. You're going to know where something like this function comes from. It wasn't just a random function, it means something. But we need to get to integrals before we can actually derive that formula. Yeah, so anyway, this position is given by that function. Don't worry about where it comes from now. We'll figure that out towards the end of the semester. Let's actually answer some questions. Where S is in feet, T is time in seconds. When will he hit the water? Find a function that describes his velocity. That's time c. What is his velocity after 1 second? What is his impact velocity? Find a function to describe his acceleration. In a test, you'll be asked like three or four parts. Let's just try to get a lot of mileage out of this one. When is he moving up or down? When is his velocity? 0. Okay. So this is a motion problem known in physics as free fall. Okay, so that's our situation. At time equals 0, a diver jumps off a platform 32 feet above a pool. His height above the water is given by that function, minus 16t squared plus 16t plus 32, which means if I know a certain time after he jumped off, I can plug it into that function, and I can figure out how high he is. Right? And s is measured in feet, and t is measured in seconds. First question, when will he hit the water? Describe his velocity. What's his velocity after 1 second? What is his impact velocity? That means the velocity when he hits the water. Find a function that describes the acceleration. When is he going up or down? And when is his velocity 0? 8 ideas.
He'll hit the water when his position is 0, so if you set S of t equal to 0,
Right. You need S of t equals 0. S describes his height above the water. When his height above the water is 0, that means he hits the water. So all we have to do is just take that function we were given, set it equal to 0, and solve for time. So what we're going to do here is find t. So this means minus 16t squared plus 16t plus 32 equals 0. How do we solve that?
Like getting
16 is a common term. Right again. Now what? And it becomes? First, it's going to be t at 2 and 1. What sign here? Minus, plus. So now I solve that, and I get t equals either 2 or t equals minus 1. At which case we reject this. We don't accept negative time in our universe. We're not quantum physics here. So t equals 2 is the answer after 2 seconds. In 2 seconds you will hit the water. Right, so if you jump off a platform, and that's the start of your position, and you're 32 feet above the water, you will hit the water in 2 seconds. V. How do we describe this velocity? First derivative. Remember that v of t is the first derivative of position. Okay, so now go and what's the derivative of that?
Negative 32 c plus 16.
Right, we're using the power rule. It's a sum of terms. We're just going to use the power rule on each term. So applying the power rule to the first one, the constant stays. You just differentiate the t squared, you get 2t. Hence you get minus 32t
Plus 16.
plus 16. What's the derivative of 32?
0.
0, because it's a constant. That's it. That function will describe his velocity, how fast he's moving. What's his velocity after 1 second? How do you get that? Just plug in v of 1. We want v of 1. V describes his velocity, so now I just want the velocity at 1 second. So that's just a function that describes the velocity. So we get v of 1 is equal to minus 32 times 1 plus 16 equals minus 16. If you want to I don't particularly care about units in this class, but that would be feet per second would be the units. What does that negative sign mean? Down. Right? So the way this original equation was set up, which I erase now, there's an assumption that direction actually makes a difference, where your velocity is negative means you're going down, your velocity is positive means you're going up. That's another concept that they use in physics all the time. And again, later on we'll actually derive that. But yeah, so negative means he's moving down and he has a negative velocity. Velocity is different from speed because velocity tells you about direction as well, where speed only tells you about magnitude. Okay. D. What's his impact velocity? That means when he hits the water, how fast was he moving? Set what equal to 0? Why do we need the second derivative?
No, it's not.
What? Why would we plug in 0 in the first derivative? What, this? I don't care about the ends. Worry about them in physics. I don't. This is velocity when it hits the water. Does that help?
Would that be the inflection point?
Do we know when he hits the water?
After 2 seconds.
Sure, we do. Right? So now I just want to find his velocity when he hits the water. I know he hits the water at 2 seconds. So I'm just looking for V2. So it's minus 32 times 2 plus 16, which gives us what? Minus 48 feet per second. I do not think he survived. That's pretty fast. To move 48 feet in a second. Yep. Didn't make it. Definitely not.
Maybe the water was deep, so use the sun to
Okay, describe his acceleration.
Second derivative.
Second derivative. Remember that acceleration is the second derivative of the position, which actually is the first derivative of the velocity, which in this case is just minus 32. Notice here that the acceleration is a constant because that is actually gravity. The acceleration due to gravity is negative 32 feet per second squared. You don't have to remember that now, but at the end of the semester you'll have to remember that. And you'll also have to remember it for physics, so you might as well remember it now.
Remember what?
Acceleration due to gravity. You drop any object towards Earth, that's how fast the Earth is going to move it. So if you jump out of a plane, that's how fast you're going to be speeding up. Huh? Yeah, you need it for physics. That's gravity. That's pretty important. That's acceleration due to gravity. It's 9.8 meters per second squared. The units here is feet. That's why it's different. So it's 9.8 meters per second squared, or minus 32 feet per second squared.
That makes sense.
Okay. Where are we now? F. When is he moving up? When is he moving down?
We'll have to see if it's increasing.
If what is increasing?
Isn't it the
Sure, one way is to figure out when is the original function increasing or decreasing. That's one good way. How would we figure that out? How do we know something is increasing or decreasing? You do f prime, and if you have f prime or the derivative, what is it? How do you know if something's increasing or decreasing?
Well, if it's less than 0.
Increasing means the first derivative is greater than 0. Decreasing means the first derivative is less than 0. And here, the first derivative of our function is actually the velocity. What we actually want now is to show that the velocity is greater than 0. That means it's going up. And if the velocity is less than 0, that means it's going down. And so now, how do I figure out where the velocity is positive or negative? Well, you first figure out where it's 0, and then you test the intervals. So, set v equals 0. This is minus 32t plus 16 equals 0. This means t equals.
Well, you said it's gone down to 0.
Huh?
Isn't that
No, this is s.
negative 1?
Isn't it
Oh, okay.
So you divide 16 and then you divide it by negative 3.
What's that? What's that? What's that?
Oh, it's
Why did that take so long? Alright, so after a half a second, his velocity is 0. So now what we do is we test at a half a second into the velocity. So you plug in a number over here. Of course, for our purposes, we will think of 0 as being something that we can't pass because we don't have negative time. And okay, so I'm going to plug in a number that's somewhere between 0 and a half. What's a number that I can put in?
0.2.
A quarter, right, or 0.25. Okay, so what would I get if I plug in a quarter? $32 divided by 4? 8. And so, is it going to be positive or negative? All I care about is the sign.
It's negative 32.
Divided by 4. We're plugging in 1 over 4 for t.
Yeah, but you
Right, so it's going to be positive, which means position is increasing here. Plug in a number over here, like a 1. Which is negative, so it's decreasing here. Right? Now I never asked you for his maximum height, but it would be a fair question for me to ask you here. Because you'll definitely know that he hits the maximum at a half, but we'll leave that for later. Maybe I'll put that on the test. So now we know that he's moving up here, he's moving down there. So this means he's going up when t is in what interval? 0 to 1/2. And he's going down when t is in what interval? 1/2 to? Now, how long does his entire journey take until he dies? 2. Come on, he's not going to survive. Right? So during that time, between 0 and a half a second, he's feeling really happy he's going up. You feel light, and then between a half a second and 2 seconds, he's in free fall. Gravity starts speeding him up at 32 feet every second.
How would the inception point apply to this?
How is it what?
Inception.
You mean inflection? Oh, it does not apply. What's the last question? Right, when is the velocity 0? Well, I've already solved that. Minus 32t plus 16 equals 0. This means t equals a half. What does this mean? When his velocity is 0, what does it mean?
Well, there's no speed, right? No velocity.
Yeah, how you describe it in what's going on in this situation.
He's not moving. He's not jumping, right?
Dying, like, that describes the maximum height. Right? We just saw here. At this point, our position function is a maximum. So, in physics, they'll probably blindly tell you that, to figure out when you have the maximum height, just make the velocity equal 0. Right? This is kind of why. And what's happened is, like, he jumps, he goes up. What happens before you start going down, you have to stop in the air for just a moment, and then you start going down. Because you have to stop to change direction. Right? So that's something you'd want to remember. You need to find the maximum height of something moving vertically, just set this velocity equals 0, and that will actually give you the maximum height. And that's the example. Any questions? Yes? Oh, we remembered that. I mentioned this before, but it's one of the applications of derivatives. Remember that? Recall. If S of t is your position function, then you take the first derivative, that gives you the velocity. Because velocity is the rate of change of position. Take the second derivative, which is the first derivative of velocity. You get acceleration, which we call a of t. So you differentiate to go down. At the end of the semester, we're going to go backwards. This you have to remember. For this class and for physics. It's a well-known relationship between position, velocity, and acceleration. It's calculus to move to move. So I don't know about you, but differentiating is getting really easy and boring. So let's make it harder. Spice things up. Let's learn how to differentiate crazy-looking functions, because the power rule is just not giving us the same thrill anymore. I feel like I'm going to jump off a cool platform at 32 feet.
I actually enjoy it.
That actually ends section 3.1. So now, we're going to be big kids. We're actually going to skip 3.2, come back to that at the end, because it's kind of applications. But right now, I just want to get all our techniques down. And so we're just going to move on to 3.3. We're going to talk about the product. And the quotient rule.
Wait, what's 3.2?
We're skipping it. I rearranged the order in this book.
Okay.
Because 3.2 is an applications thing. It's like a lot of word problems and stuff. I just want to stay with the techniques. So now we're going to do the product rule and the quotient rule. Then we're going to do 3.4, which is the chain rule, which allows us to differentiate more complicated functions. So I actually asked this in the on the quiz as a bonus. How do we find the derivative of two functions being multiplied together?
F prime of x
Times g of x plus f of x times g prime.
Right, that is called the product rule. How many people just put f prime times g prime?
No, I didn't, but I put the d over dx.
You just left it blank, right?
No.
As it turns out. You can't just differentiate. Just a warning. The derivative of f times g is not f prime times g prime. Right? Watch out for that mistake. It's not true. It's not hard to prove it. Here's a check. What's the derivative of x squared?
2x.
2x. What if we instead wrote it as x times x, which is x squared? And if you differentiate each piece, what would you have gotten? Derivative of x would
would just be
be
1.
1. The derivative of x would be
1.
1, which would give you 1, which you know is not the derivative. Right? So you don't have to go far to find an example where this just doesn't work. So if I can't just differentiate each part of a product and get the derivative, what do I do? Well, here's where the definition comes in. we're going to use the definition to figure out what we need to do to differentiate a product, because that definition tells us how to define a derivative. So by definition, if I want to take the derivative of f of x times g of x, what would that look like?
F prime.
Definition.
So isn't f prime the limit of the definition? F prime of x, or?
No, what does the definition say? What's the first thing?
F prime x plus b.
Becomes closer.
That is by definition how you find a derivative. You plug in x plus h into minus the original function divided by h, let h go to 0. So now we're going to see what this actually gives us. Here we're going to use a cheat trick. It's going to be the limit as h approaches 0, which we use this trick all the time. You learned it in computing the square. You kind of sneakily add and subtract a number so that you're adding and subtracting 0 and not really changing anything. So, first thing we're going to do is I'm going to add and subtract this thing. Why'd you do that, John? Let's see what's going to happen. Can I simplify it? So now what we're going to do is we're going to actually factor by grouping. Here, do we see a common term? The g of x plus h is a common term, which means I can factor that out. So I have f of x plus h times f of x plus h minus f of x over h, and I factored off that g of x plus h plus, ran out of space. I'm going to do the same thing here. In this case, my f of x is the common term, so I'm going to factor that off, and I'd actually be left with g of x plus h minus g of x h. Things are starting to look familiar now. Now we can take the limit. The limit rule says if I have a product of two things and I'm taking the limit of the product, I can take the limit of each part, assuming they exist. So the limit of the first thing, as h goes to 0, f of x plus h minus f of x over h, what is that? That is just f prime, by definition. Times, what's the limit of g of x plus h as h approaches 0? You just get g of x. Plus, f of x doesn't change as h goes to 0. And then what's the limit as h goes to 0? G of x plus h minus g of x over h, that is g prime. This gives us another rule. The derivative of a product of functions is the derivative of the first times the second plus the first times the derivative of the second. F prime times g plus f times g prime. This is called the product rule. Well, it's multiplication and addition, so the order doesn't matter. I would definitely recommend you memorize it in this order, because the next rule, the quotient rule, the order will matter. This order is actually nice for that one. So you kill two birds with one stone by memorizing it in this order. So order really doesn't matter here, but I've memorized it in this order. Use this when you need to differentiate a product. That's why it's called the product rule. A product is a multiplication of functions. So hopefully your algebra skills are good enough to recognize when two things are being multiplied. They're just right beside each other instead of multiplying. And you might see a dot, you might not see a dot, but when you stick two things beside each other, multiplication is happening. So that is called the product rule. This is now something we know now. This needs to be memorized. Very, very, very important point. Let's go back to our first silly example. Does this work for x squared? Well, let's check. What if I went the long way and clicked the bottom that says x times x? Then, by this rule, what would happen? That means this would be my f. I think of that as my g. And so the rule tells me what? F prime goes here, which would be what in this case? 1, because derive of x is 1 by the power rule. Times the original function, right? So this is f prime, and this is g. Plus f, which is just the original function here, times g prime, derivative of x is 1. So I get x plus x, which is 2x, as expected. But that's too easy. I mean, if you have to differentiate x squared, you'd never actually do that. You just use the power rule. But let's do something that is not so nice. How about how would you differentiate x times e to the x? So you look at that and you're like, hey, it's not just an x by itself, it's not just an e to the x by itself, they're stuck together beside each other.
So would it be
That means there's a multiplication.
1 times e to the x
Yeah, 1 times e to the x. And then
plus x to the e to the x?
So what are we doing?
Yes. So it's
So the first thing is you identify who you want to be the f. You can write this down if you want, I don't care if you write it. But eventually you should get to it so you can just know that this is the first function I'm calling the f, the second function I'm calling g. So the f prime, which is
So it's 1
it's 1
times
times ts
times the original function
plus x
f
times
times
e to the
yes.
x. E to the x.
So you get e to the x plus x e to the x. And that will be the function that describes the slope of this function. That is the derivative of x times e to the x. And you have to go through that rule because it is a product. Right? So I couldn't just differentiate this and differentiate that and get e to the x. That would be very, very wrong. Okay.
One over 2.
First thing, rewrite it. I don't have a rule where there's a radical in the rule. So I can rewrite it as it's x to the 1/2 power is what I have. And so now that looks like something I can apply a rule to.
Yeah, half x is equal to the negative x of x.
Right? So this is my f prime, that's the g. Alright, so I differentiate this guy, but I leave that one alone. Plus, do the opposite, leave the first one alone, and differentiate the second one, which is 1 over x. Can I simplify that? Well, this one I can simplify. What does that give me? X to the half times 1 over x.
1 over 2x. 2 square root.
So what is,
It's just.
No, wait.
I'm talking about this one.
It could be 1 over square root of x.
Right, but that can simplify because these are powers of x's.
Square root of
Multiply.
x over x.
Because you 1 over x to the half, you subtract the powers, right? This is x to the 1. So it just becomes x to the 1 half minus 1, and you get minus a half. So that's just 1 over x to the half, or x to the minus a half, whichever one I don't really care about negative powers at this point. And you can factor that if you want. That's the derivative of that function.
I have a question.
Yes.
I know we're going to get to the quotient rule, but can't, like, let's say you have like a fraction, right? Would it be a smart idea to take a fraction and like multiply it? So like, let's say it was x plus 3 over x squared. So then would you do x plus 3 times x to the negative 2 and then use the product rule?
In that particular example, it's even easier. I wouldn't do that because you can just divide.
Yeah.
So in that particular example, you want to differentiate x plus 3 over x squared. I would just rewrite that as instead of 1 over x plus 3 over x squared. And I can use the power rule on that. This is just x to the minus 1 plus 3x to the minus 2. And so I would just get power rule here, minus x to the minus 2 plus minus 6x to the minus 3. So that's how I would have done that. But I see what you're saying. You wanted to bring this up and use the product rule. Yes, you can do that. That's always enough.
Like for example, for the answer to the first, well, the second one you did, I left it at a lot of x over 2 times the square root of x. You don't want it, if you want it.
It's the same thing.
It doesn't matter to you?
That's something you just torture algebra kids with. It's, who cares if there's a negative power? Oh my god, there's radical in the denominator. Don't care. Did I have another example? What about this one? Dum dum dum.
It's 5 times 3. X
Would it be
is
15x squared?
15x squared.
I didn't catch them. Okay. If it's a constant, don't waste your time using the power rule because you can always factor constants out. Thought I'd catch it. I was hoping to like throw the chalk at somebody. If one factor is a constant, don't waste the time on the problem. Just factor out the constant, do what you did before. Sometimes students have a tendency, once they learn something new, they forget what they knew before. Just want to make sure that you guys are doing it. Here's a task I'm going to give you guys to do. You'll see why afterwards. What if I wanted to differentiate something like 1 over 2x?
Wouldn't you find the derivative of the numerator times the denominator minus the numerator times the derivative of the denominator over the denominator squared?
Why would you do all that?
Because that's the difference.
Because that's the rule.
Yeah.
What rule? I didn't give you guys any rule. It's like,
Well, you made us study for it for the quiz.
jeez. The kids are all grown up and reading. I'm so proud. But let's have some fun with the definition. And we'll see why that is the case. How would you simplify that? Multiply by density over itself, that's how we deal with complex fractions. So we don't freak out and get scared, oh my god. Multiply by that then. And let's see actually what happens here. So this times that g plus h is canceled, you get g of x, minus this times that, g's cancel, you get g of x plus h over, you get h times g of x times g of x plus h. Now notice how I'm going to rewrite this guy. I can factor out a negative sign to turn this guy around and factor the h off. And then I would have here so I kind of factor off the denominator. What's happening is, by definition, this guy here is actually just the derivative of g. So this actually gives me negative g prime times, here if I plug in h equals 0, I just get 1 over g squared. In other words, I get minus g prime over g squared. Why was that useful? Now we're going to figure out the rule that everyone already knows, so now it's just like, it seems less magical, but it's still magical. Task. I now want to differentiate something that looks like f of x divided by g of x. Let's actually divide functions, figure out how to differentiate that. Well, the thing is, I can rewrite this. It's that, right? So this is one function times another function. I know the product rule. The product rule says, differentiate the first guy, leave the second one alone. Plus, you leave the first guy, and you differentiate the second guy. Now we already derived that the derivative of that guy is that guy. So this is minus g prime over g squared. Alright, of x. Let's actually f prime over g plus, well, this would be minus f times g prime over g squared. Now what we can do is, we're adding fractions, create a common denominator, multiply by d over g. And so what we end up with is f prime times g. Let's write this here. F prime times g minus f times g prime over g squared.
Wait, can you explain how you went from negative g prime back to that?
What about negative g prime?
How did you get from that up there? From like the bottom of that board back?
Oh, here, this is just the answer for that.
Oh, okay.
And that is the start of a whole new task. That's a
Okay.
whole new problem, right? So, but I use this fact here, there, right? To figure out the derivative of the 1 over g, I use this.
Okay.
I just plugged it in, and then I simplify, and I got that. Which leads us to another very important formula.
Another one.
The derivative of one function divided by another function, of course assuming the bottom function is not 0, is f prime times g minus f times g prime over g squared. And this is something that we know now. This is called the quotient rule, because it's used to differentiate quotients. So you use this when you want to find the derivative. Of a quotient. Fancy way for saying division. So if you have a sum or a difference of functions, it's easy, just differentiate each part and stick them together. It turns out if you have multiplication or division, it's not that easy. You have to go through this whole thing, which we derived from the definition, so it's kind of how it has to work.
Jhevon, I have a question.
Yes.
Do we have to derive that in our final?
No, just know this.
Just
You can forget it all. Just know it. Just how when you know it, if you know it, you kind of lose some of the. But I guess now you get a better grade on your test, so it makes up whatever. Okay, so this is the quotient rule. It's very important that you remember these rules. So if you see a division of things, you can't just differentiate the top and differentiate the bottom. That is incorrect. You have to go through this process. Now you can see why the order of the product rule is important, right? Differentiate the first, leave the second. The negative sign means that you can't switch the order, because it will actually change the value. There are tons of ways you can remember this. There are lots of mnemonics. There's low D high minus high D low over low squared. People make up all sorts of things. Yeah. We're doing too much. Change the surface, are you kidding? We just started calculus last class. You're insane. Okay, this is called the quotient rule. Pretty much like for the last half hour I've been talking, the only thing you need to remember is what I put in the box. The product rule and the quotient rule. You can forget everything. Make sure you know this.
So was it just to waste time then? Like,
Yeah, just, you know. At least you guys are dragging things out. You can spend some time here. Let's do some examples. What about something like this? Differentiate x plus 1 divided by x plus 2. So here you realize that I have one function, which I can call it f, divided by another function, which I can call it g.
So we do.
And so now,
It's going to be
I know I'm going to do f prime times g
1.
minus f times g prime. Now f prime would be, derive this, is 1 times the g is plus 2 minus
1.
f, which is the x plus 1, and in parentheses, times the g prime, derive the bottom. just 1, divided by
X plus 2 squared.
bottom squared. And of course, we're going to want to simplify that. Can that be simplified? How do we simplify that?
It'll just be just 1.
Wouldn't you want to put everything in a parentheses?
X.
Well, like, let's say it wasn't 1 there.
What?
Let's say it wasn't 1 there, and it was like, it was X. Wouldn't you want to put all of it in parentheses? Because there's a subtraction sign.
Yeah, it'll be the same thing though.
Okay.
Exactly the same.
All right. 'Cause-
Right, if I have this, then that.
Right, right, it doesn't matter.
You can put it just in case, just be safe. Not necessary. So here, x plus 2, the negative sign will distribute. You have x minus 1, or x plus 2 all squared. The x's will cancel. 2 minus 1 gives us 1, so I get 1 over x plus 2 squared.
Why couldn't you just like cross out one?
Cross out what?
The X was the on top and one was
Because we cannot cancel across zones. That would be a very big mistake. There's a minus sign here, so I can't cancel. So that would be the answer. Derivative of that guy is this guy. Well, this one. What? How do we do that?
It would be
2x
yeah, 2x
times 2
times
minus x squared times
0.
0
2x times 2
over
minus
X squared times
0
0.
over 4. So then it would just be 1/2 x.
Why would we do that? I caught you.
Wait, what?
Why would we do that? It's a power rule. Alright, this is just a half times x squared. X is the answer.
Alright.
Right?
Well, our way wasn't wrong either.
No, you're
Then we
not
just
wrong.
went to-
But when you do something like that in a test, trust me, the chances of you making a mistake are really high. I see it all the time. Because some people would forget that the derivative of 2 was actually 0 and all that stuff. Or the same thing would be for if I gave you something like this.
There is a constant 0.
I would not use the quotient rule on that either. I would just rewrite and use the power rule.
X to the negative.
Yeah.
So that's just minus 4x to the minus 3. This is just a tip. You can do the quotient rule on that if you want, but if you get it wrong, no mercy. So tip, if the numerator or denominator is a constant, don't use quotient. I've seen people use it in simple situations like this, and it just messes them up. Well, let's do one of the quiz problems. I gave you guys a quotient rule one. Remember this guy? What'd you guys do for that?
Make them over.
Power rule on both.
Right, if there is one term in the denominator,
Yeah.
divide it into each.
Yeah, and then you kind of.
Right, so you wouldn't try to do the quotient rule on that either. So this is just a derivative of, let me just write it out. 4x times x squared minus 3x squared over 2x squared plus 2x over 2x squared plus 3 over 2x squared. So you just divide into each. You won't always be able to do that, but if you see one guy in the denominator, it's something you're going to want to try. Even if the guy's not a constant,
That was on the.
it's something you should consider doing, because there's just one guy in the denominator. You can just divide it. And so this is just the derivative of 2x squared minus 32 plus 1 over x, or you can write that as x to the minus 1 plus 3 over 2 x to the minus 2. So now we just do the power rule. So this becomes negative third power. And we could actually combine those. Let's just combine those. So this is just 4x minus 5x. It's not so bad, right?
We should get a.
Wait, so then why didn't you use the quotient rule for that?
Oh, time flies. Oh, just getting warmed up. Yes. You can't do that. Like you just do print to the top and then print to the bottom. Yes, you can do that. That's actually that's what the question is. Okay, so we'll pick up next time. I have stuff to give back to you.
I think it's the same thing, it's just
Oh, time flew.